What is Jacobian in multiple integrals? Jacobian is useful when we change variables in multiple integrals. Suppose in multiple integrals we change the variable. If the variable is u and v and we change it to x and y, when you change the variable in multiple integral, that is surface integral or volume integral, so in this case we use the Jacobian matrix. Suppose you have a transformation function from S to R. So this is the transformation function, and S is a function of u1 v1 and R is a function of x1 y1. This is your, suppose xy coordinate, this is your uv coordinate. So when you change the function or when you transfer the function from S to R, you need Jacobian matrix or Jacobian determinant. Again you change the function from R to S, the transformation will be T inverse. In this case also you apply the Jacobian matrix or Jacobian determinant. The Jacobian matrix simply written as J. Jacobian generally written by the term J, and Jacobian is a matrix often simply called the Jacobian. When it is a square matrix, we call it determinant. Thus, Jacobian matrix or Jacobian determinant or simply Jacobian is the determinant of all first order partial derivatives of the transformation function. When you take the transformation function or transfer the function, we will take the first order derivative. So Jacobian is the determinant of the first order partial derivatives of the transformation function. For example, suppose you have two functions u and v and two independent variables, suppose x and y. So the determinant of the change in u and v can be written as, with respect to x and y, can be written as partial derivative of u with respect to x, partial derivative of u with respect to y, then partial derivative of v with respect to x and partial derivative of v with respect to y. And here we called u and v with respect to x. When you take the partial derivative of u and v with respect to x and y, this is called the Jacobian of u and v with respect to x, y, and it is generally represented by j u v with respect to x, y, or that is equal to the partial derivative of u v with respect to x and y. So here you have two variables, x and y. If you have three variables, so the Jacobian of u v w written as Jacobian of u v w with respect to x and y, x, y and z is equal to partial derivative of u v w with respect to x, y and z. And we take the determinant of partial derivative of u with respect to x, then determinant and then partial derivative of u with respect to y, partial derivative of u with respect to z, similarly partial derivative of v with respect to x, partial derivative of v with respect to y, partial derivative of v with respect to z, partial derivative of w with respect to x, partial derivative of w with respect to y, and partial derivative of w with respect to z. And this determinant or the square matrix will give you the Jacobian of the variable function u, v and w with respect to x, y and z. We represent the Jacobian of the functions like this. Similarly, if you have four variables, you write Jacobian of four variables u, v, w and another variable with respect to four functions u, v, w and another function with respect to four variables x, y, z and another variable, and we write determinant of 4 is to 4. So in this way you can find out the Jacobian of any given functions with respect to the independent variables by taking the determinant of the first derivative of the transformation function. Thank you.